I picked up something that looks like gold, and it has obvious markings on it. Just by looking at its appearance, it's hard to tell if it's real or fake. I bit into it a little, and it left a clear bite mark on the surface. When I broke it a bit, I found that it was really very soft. You can do whatever you want with it. It's just like real gold. Let's test it with some concentrated hydrochloric acid. For comparison, there is aluminum foil in the small bottle next to it. Pour the same concentrated hydrochloric acid into it. There is no reaction on the left side, but the aluminum foil on the right side has started to bubble. It all dissolved immediately. Now let's soak it in concentrated nitric acid, and split some of it over to the copper piece next to it. You can see that it immediately started reacting and released brown nitrogen dioxide gas. The one on the left is still very stable, and the color hasn't changed at all. It should be pure gold. Is gold so strong? It is not afraid of hydrochloric acid or nitric acid. Now let's soak it in 5 milliliters of concentrated hydrochloric acid, add 1 milliliter of concentrated nitric acid, and then heat it up. Ah, did you see that? Finally, there's a reaction. It's bubbling, and as the temperature rises, the bubbles are getting more vigorous. The concentrated hydrochloric acid and concentrated nitric acid are mixed in a 3-to-1 ratio to create aqua regia, which has a very strong oxidizing ability and can successfully dissolve gold. This method has been used in the field to avoid detection by others. Soon, there's just a frame left. It took only 20 minutes to complete everything, and it's very thorough, with no residue at all. If this bottle of yellow liquid is mixed with other bottles, it would indeed be hard to detect that it's gold-related. When needed, pour it into a beaker and add sodium sulfite to reduce the gold. These particles look brownish, mainly because they are too fine and hard to reflect light. Keep adding until no more precipitate appears. After washing the precipitate, filter it out, and you can see the gold powder on the filter paper. Once the moisture dries, put it in a dry pan and burn it directly along with the filter paper. With 2 torches going, the speed is faster. Alright, it's turned back into a little gold bar. Why are there so few people here? I bought a stainless steel climbing cup, and it looks too plain, so I decided to plate it with a layer of gold. I dissolved the little gold bar again in water to make the electroplating solution. I prepared 4 grams of yellow water salt, which is potassium ferrocyanide, dissolved in 200 milliliters of water. Then I added 5 grams of potassium carbonate and heated the mixture, keeping the pH around 12. Now let's add the gold-containing solution we made. After heating for another 30 minutes, you can see a lot of hydroxides precipitating out of the solution. During this process, potassium carbonate can also be added to increase conductivity. After filtering, we obtain a gold-containing electrolyte that can be used for gold plating. And now we have the electroplating solution ready. I still need a piece of gold to make a soluble anode. Luckily, my cousin has a gold-containing bracelet that looks really beautiful. First, I'll cut it, and then cut it into smaller pieces for easier handling. It weighs less than 14 grams, and based on the stamp on the bracelet, I can estimate that the pure gold content should be around 5 grams. Let's extract it first. The method of operation is the same as turning gold-containing jewelry into pure gold. After drying, add the gold powder to the borax crucible and refine it with a torch. This dry pot is too large, causing heat to dissipate too quickly, and it takes forever to melt. It's better to operate like this on charcoal. It quickly melted into a lump. Now it's pure gold. This thing indeed looks nice. I weighed it, and it's 4.8 grams, which is about what I estimated. Let's copy it to increase the surface area. Making it like this is about right. Fix it as a soluble anode. Here, place the stainless steel cup inside as the cathode. Look at this power source. Can you see it? It's already starting to bubble. The anode continuously oxidizes, supplying plating ions itself. The metal ions in the plating solution move towards the cathode, gain electrons, get reduced, and deposit on the surface of the cup. It's not fully submerged like this, and flipping it back and forth is too troublesome. I diluted the solution a bit more, and now it can be fully submerged. I left it soaking like this overnight, and it's finally done. This piece of gold only used up a little bit, and now it indeed looks much more upscale. However, the details are a bit lacking. The bottom of the cup and the cup itself are still okay. The outer part of the north wall is actually exposed. This won't do. I need to consult a professional. They suggested that directly gilding on the tank doesn't yield good results, and it's better to plate nickel first and then gold. I prepared a stainless steel folding cup, cut it into small sections with a straight grinder, placed them in a box, and poured alcohol to soak them, removing grease and contaminants. This way, it's very clean. Then, prepare a 10% hydrochloric acid solution and soak it for a while to make the surface rough, increasing adhesion. That's it. Place it in clean water. Clean the anode. Insert a piece of liquid nitrogen. And then, put the treated steel strip as the cathode. Arrange the current in a 4-to-1 ratio. After 5 minutes, take it out And see, the surface is already evenly covered with a shiny layer. The same operation was also used to plate a knife, a poor quality outer shell, and a nail. With the plating solution, initially, a cup was plated. Now the concentration is insufficient, so I have to dissolve this piece of gold again. Is the method of depiction still the same as before? Now the gold content is there, but the soluble amount is gone again. So I had to borrow a solar collector with a healing oxide coating from a friend who makes circuit boards. It belongs to the category of insoluble anodes, which do not dissolve themselves when current passes through, indicating an oxidation reaction occurs. If I had known about this thing earlier, I wouldn't have had to use my cousin's gold bracelet. After adding it, look at how good the effect is this time. Just polish it casually with fine steel wool, and the luster comes out too. The effect is top-notch. The operations for Sherry's co-construction are all the same. Similarly, soak it to make it shiny, and everything is sorted. Then assemble it into a complete object, and the appearance is top-notch, directly boosting its value a bit. Especially this golden knife, it's simply irresistible. First, use the golden knife to cut a piece of sushi, then cover it with a piece of gold leaf, using gold foil paper. Simply perfect.